All right, welcome to lesson 5.02. We're going to continue working to identify the key features of exponential functions in order to graph them more efficiently. Let's get started. Okay, so this is the definition that we've seen already, and this is the general form of an exponential function. Notice that the independent variable is in the exponent. All these other pieces here are parameters. In other words, they're going to be constants that aren't going to change, while x actually does the changing. However, the value of these constants or these parameters is going to tell us a lot about how the function looks when it's graphed, a lot about how it behaves. And so we want to figure out how changing those parameters will change the graph of the function. We already looked at the base, and we saw that if the base, the b value, was between 0 and 1, then we were dealing with exponential decay, meaning that the function is decreasing as x approaches infinity. And to be more precise, and this is something you want to make sure you have down, the smaller that b is, the faster it will decay. If b is greater than 1, then we have exponential growth, which means our function is increasing. And to be more precise, something you want to make sure you have written down is that the greater that b is, the faster it will grow, right? Doubling, tripling, quadrupling, great examples of that. Now we're going to try and find out what each of these other parameters does to our function. So to do that, we're going to graph a bunch of different functions and see if we can tease out what effect changing a or k or h or c has on the function. So I'm going to go ahead and move to the next page, and I'm going to give you these test cases to try out. Once you've gone through and followed the directions on the next slide, you're going to come back and, to the best of your ability, you're going to hypothesize, make your own hypothesis on what a, k, h, and c do. What transformation do they impart on the graph? So try and use mathematically precise language like translate or reflect or any of those that we've seen previously. Okay, so here are the test cases that you are going to do. Now, notice the directions. Graph each pair of functions on the same axes and use the comparison to make a hypothesis about the transformation that each parameter causes. Now, that means you're going to have one set of axes for each pair. So you'll have 1, 2, 3, 4 different sets of axes, and on each axis, you're going to have two curves sketched, f of x and g of x for each. All right? Now, if you want, you can make a table to sketch the graph of each, so you can, just like we did in 5.01, and you might go back and take a look at that. Or you can go ahead and plot the points in your head. So for example, I can do this in my head because I know 2 to the 0 is 1, and then I can add that to 3, and I can do 2 to the 1 and add that to 3, and so on and so forth. But you might need to do a little bit of calculation on the side to make sure that you're doing it correctly. Once you've done that, once you've graphed all of those, then you'll want to go back and actually write in your hypothesis for the transformation that each parameter causes.